So I'm going to talk very briefly about the next um, few things. Actually, I think I'm just going to very briefly talk about this and then I'll cut it off. I'll stick to nice short videos. Okay. So I'm not going to really mention much about gases and chemical reactions in these lectures because we're going to be doing that a lot in our calculations. We're going to be doing a lot in the semester as we continue to talk about gases and chemical reactions. So I just wanted to mention a few examples. Stuff we've already talked about, combustion of hydrocarbon, right? And up to now, we've typically given you, like what mass of carbon dioxide do you get out of this equation? We don't really ever measure the mass of gases, in all honesty, okay? We measure the volume or the pressure of a gas. So a better way to do these combustion reactions would be use PV equals nRT, right? Because we typically will know a volume of a gas or pressure of a gas, not the mass. Airbags. This is actually kind of just one random cool example. So this thing is called sodium azide. Azide is a particularly weird polyatomic ion. It's N3 minus, the azide polyatomic ion. So obviously I did not make you memorize every single polyatomic ion that there is. There's a lot of them. So sodium azide is particularly explosive, and a very small detonator cap will create a spark with this thing, which causes this sodium azide material to explode. It makes sodium solid, which doesn't really change the volume much, but look, it makes nitrogen gas. And I just said it explodes, but it's not like a combustion explosion. It just evolves gas, and it does it very quickly, right? Because what happens as the car is impacted, this little electronic senses that impact, okay, and releases the detonator cap, which detonates the sodium azide, and very explosively and quickly fills this airbag with nitrogen. In fact, that's why it can break your bones, because there's so much pressure of nitrogen that gets created, and it's so explosive that when you come into contact with that in the wrong way, like your elbow hits the airbag or whatever, it can break your bones. Of course, better than flying through the windshield, right? So this is really cool. Oxygen generators on the space station or even in airplanes and really high altitude airplanes. So we recognize this is sodium perchlorate, okay, which also can undergo a pretty explosive reaction under the right conditions. Okay, chlorates, perchlorate, so ClO3, this is pretty explosive stuff. And mixed with an iron catalyst, it makes these two solids, sodium chloride solid and iron oxide solid, but it generates oxygen gas. So these things are done in a much more controlled environment, not like the airbag that just needs to inflate all that gas at once. So these typically will make oxygen in a much slower, more controlled, non-explosive way. Because of course, if you were on an airplane, the last thing you'd want to do is blow it up by accident because you're trying to make oxygen for people to breathe, okay? So this says, we will explore gases and chemical reactions more in the discussion. So in your discussion worksheets, I'm going to give you more examples. But basically what it comes down to is we use the ideal gas law, right? We solve for N. N is PV over RT. And if we're given, some conditions in our chemical reaction, like what's the pressure, what's the volume, what's the temperature, that's going to be able to give us number of moles. And then from there, we can use, these balanced chemical reactions in the same way we've been doing. So there's really not a whole lot of difference here, okay? We're just kind of slightly changing the way that we do our stoichiometry by using the ideal gas law to calculate number of moles, okay? So I think I'm going to end the video from there. Let's see if I have my... where did my learning goals go? I'll bring up the learning goals of the next slide and summarize. Okay, folks? So I'm going to anticipate 2 more videos. So we'll have 4 videos in total for gas laws, So I'll anticipate 2 more of about the same length as these previous 2. Okay, folks, I'll see you in the next video.